Hello once again, thanks for joining me. This is Astronomy Daily, where we talk astronomy and space science that's in the news. I'm your host, Andrew Dunkley, and I hope you're well. Coming up on today's edition, we're going to look at the edge of our solar system. It's been the subject of a recent study, and it looks like something weird is happening out there. We're also looking into an investigation that's being bankrolled to the tune of several $1 million to try and find what some believe is a UFO that's splashed down in the Pacific. Okay, we'll check that out. What of the future of telescopes, those that are on Earth rather than in space? Is there going to be anything we can do with them going forward? Well, the answer is yes, and the way they're going to do it might surprise you. And an Australian rocket that's being built, almost completed and ready for launch. That's all coming up on this edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And we say hello to our AI reporter, Hallie. Hi, Hallie. All ready for work?
Hi, Andrew. Yep, sure am.
Okay, let's hit it.
Firstly, some news from NASA. Artemis 1 has made a close approach to the Moon, flying within 130 kilometers above the far side of the lunar surface on November 21st. The Orion capsule blasted off on top of the enormous Space Launch System (SLS) rocket, the most powerful ever launched, on November 16th. After years of delays and several missed launch opportunities this year thwarted by hydrogen leaks, technical issues and, most recently, a hurricane that SLS weathered on the launch pad at Cape Canaveral in Florida, the liftoff went astonishingly smoothly. Orion is expected to enter orbit around the Moon on November 25th. Then, after 6 days in orbit, it has got to come back, a part of the mission that is just as crucial as the launch itself. It is expected to return to Earth on December 11th. Still at NASA, the space agency says a historical review of actions by former Administrator James Webb confirmed its decision to keep the agency's flagship space telescope named after him. NASA released an 89-page report by the agency's chief historian, Brian Odom, reviewing allegations that James Webb, first at the State Department and later at NASA, was directly involved in the firings of employees based on their sexual orientations. Those allegations had led many astronomers to call on NASA to rename the James Webb Space Telescope. The study found no evidence to support those claims. Odom said, in conclusion, to date, no available evidence directly links Webb to any actions or follow-up related to the firing of individuals for their sexual orientation. A research team led by Israeli scientists has found 2 new giant planets in remote solar systems. The planets are made mostly of gas and are about the size of Jupiter, which is 1,300 times bigger than planet Earth. They are located so close to their suns that they can complete an orbit in less than 4 days. Researchers from Tel Aviv University headed a team that used data from the European Space Agency's Gaia spacecraft to identify the planets Gaia 1b, which is 1,186 light-years from Earth, and Gaia 2b, which is 682 light-years away. Finally, when you think of the leading nations in astronomy, you don't generally think of Bosnia and Herzegovina. It's the only country in Europe that does not have astronomy as an institutionalized science, nor does it have its own observatory. That might soon change thanks to the long-term initiative of Dino Gipa, one of the leading astronomers in BIH and a member of the Astronomical Society Orion from Sarajevo. Brizik Tower, which used to serve as an observatory, was destroyed by the war in the 90s. We want to restore science and personnel and, in cooperation with the University of Sarajevo, we want to establish a Department of Astronomy and Astrophysics, where personnel will be trained to operate the expensive equipment that will be used in the observatory, Gipa explained. And that's the news, Andrew.
Sounds like a lot of positive things happening in space science today. Thanks very much, Hallie. We'll catch you at the end. Now to some other news. There's much we've learned about our solar system thanks to the journeys of space probes like Voyager 1 and Voyager 2, and they're still giving us data. In fact, there's something new to report, and it doesn't appear to be great news. scientists have noticed a series of changes in our heliopause. That's the border between our solar system and interstellar space. The heliopause is basically the final barrier between our solar system's space and that of the interstellar medium. Now, because of this, changes in the heliopause have always been intriguing to scientists, but new data points to some terrifying changes, their words, not mine, that our current models of the heliopause can't explain. The changes were discovered while looking at data captured by NASA's Interstellar Boundary Explorer, IBEX. That satellite captured several brightening, energetic, neutral atoms that indicated a lack of symmetry in the heliopause. Now, if you back up a little bit, the findings were reviewed through data from Voyager 1 and Voyager 2, and they found that changes in the heliopause had definitely taken place. The scientists also found that the changes in the heliopause in the time between when Voyager 1 and Voyager 2 entered interstellar space was so drastic that they defy the current models that we have regarding our solar system's boundary point. These so-called drastic changes could also explain why there are such large gaps between the two probes entering the interstellar medium. Researchers published a paper on the topic in the journal Nature Astronomy earlier this month. In it, they call the changes in the heliopause potentially controversial. They also plan to continue studying the boundary of our solar system and will use NASA's Interstellar Mapping and Acceleration probe to try and understand the changes better, because they really can't explain them or what their effect might be. Until then, though, scientists will have to rely on spacecraft like the two Voyagers and the current data we have to learn more about interstellar space. Now to a story from the popular press, and I'll leave it to you to judge whether or not it's fact or fantasy. A professor, well known to us, from Harvard University is on a $2.2 million recovery mission to determine if a mysterious meteorite that crashed near Australia almost a decade ago is a UFO. As a part of the expedition, astrophysicist Avi Loeb will search the floor of the southwestern Pacific Ocean for what he believes may be an alien spacecraft. Now, he stated that the material of which it's made is tougher than iron based on the data. So the question is whether it's just an unusual rock or perhaps a spacecraft from another civilization. The unknown object came down in the Pacific Ocean in 2014, about 160 kilometres off the coast of Papua New Guinea, which is just north of Australia. Scientists believe it was travelling at 45 kilometres per second. Earlier this year, the US Space Command confirmed the article came from another star system and was the first interstellar meteor to ever hit Earth. But Professor Loeb, who heads up the Galileo project, which is working to capture a high-definition image of a UFO, believes otherwise. Professor Loeb added that he has received full funding for the expedition to scoop the ocean floor and retrieve the object, and that any find would be displayed in the Museum of Modern Art in New York City. Social media was divided over the news and whether extraterrestrial life exists. As I said at the start, you decide for yourself.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, what of the future of telescopes? Fred Watson and I touched on this subject recently on Space Nuts when we were asked what kind of future there would be for smaller ground-based telescopes. Well, NASA is working the problem, sort of. The most likely future of Earth-based telescopes might be not to keep them on Earth at all, but not launch them into space either. NASA has a balloon program analysis group, and they're working on future astronomy programs which will use balloons as their main platforms. Now, balloons have been used for over a century to conduct physics experiments and astronomical observations and Earth observing work, but they remain relatively unknown to the general public. Balloon astronomy shares many advantages with space telescopes, but at a fraction of the cost. Modern balloon missions serve a wide range of scientific fields. Cosmic ray observations, for example, are a valuable source of data for particle physics experiments. Cosmic ray particles often carry energies far greater than what scientists can achieve in particle accelerators like the Large Hadron Collider. So these missions can collect valuable data by watching for collisions between cosmic rays and air molecules in the upper atmosphere. But balloons often perform more traditional astronomical observations as well. Small telescopes, less than a 1 metre aperture, are often hoisted above the atmosphere to study exoplanets. They can directly observe protoplanetary dust belts around stars and detect new exoplanets using the transit method. Balloons can position scientific instruments and observations at a high enough altitude to gain many of the benefits of observatories in space, but with few of the drawbacks. And because these missions are cheap, they can tolerate a much higher level of risk, and balloon missions also have a very high rate of recovery. They can also carry quite heavy payloads, so it seems the future of high-altitude balloon astronomy is assured in the years to come. Now, I do have one more thing, and this is from the Australian company Gilmore Space. They've almost completed building a rocket, and they're planning an Australian launch in April next year. And this will be Australia's first home-built orbital spacecraft. Adam Gilmore is co-founder of the company and says space is one of the key enablers of society, and it's good for a nation to have access to space capability if it can. And he's putting his money where his mouth is. The Eris rocket, as it's known, will stand at 23 metres and weigh in at approximately 30 tonnes. The power source will be 5 hybrid engines containing solid and liquid fuel, as well as a liquid oxidizer. Well, we'll certainly be watching with interest, and we'll report on how that launch goes if it happens on time in April next year. Very exciting for Australia. And that sort of dovetails well with the recent establishment of the Australian Space Agency. We're just about done. Anything more from you, Hallie?
Nah.
Okay, we'll see you later.
Bye.
Oh, I almost forgot. You can chase up all of these stories and more at astronomydaily.io, and you can also subscribe to the Astronomy Daily newsletter while you're there. Until next time, this has been Andrew Dunkley for Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.